This is linear algebra. We're going to discuss matrix transformation in this video. First, we're going to introduce the definition of a transformation. Transformation is basically function, which we studied the algebra class. Function is, what is a function, guys? Remember the function? They have domain, one set, they have another set. So define the function of f, that's part of rules, right? Then you say rule gonna be x plus 1. Here is a real number, here to the another real number. So you're gonna 1, that's go to the 2. That's what we call function, right? Transformation is domain is different, not real number Rn. So here is Rn, here is Rn, go to the another set Rm. So we're gonna define the T, we call this is a transformation. You pick the one vector here, that's the x, correspond to the T of x in the Rm. That's we say transformation, guys, okay? So how can define the transformation? It's not easy task to define the transformation. That's why we using the matrix. How can define the transformation? We're gonna use matrix, okay? So when you pick the one vector in the Rn, go to the RMTX, we're gonna define the metric A, that's gonna be A times X. That's how to define the transformation. So we call this is metric transformation, guys, okay? Very simple example, guys. Look at this one. This is X vector, so we have two components. So this one is gonna be R2. That's the vector in R2. Matrix A, guys, matrix A, what is the size of matrix? 1, 2, 3, 3 row. 1, 2, 1, 2, 2 column. 3 times 2. So this transformation by using the matrix, here is a vector x. That's going to be R2. Go to the T of x. That's the function. We're going to define this image. So A times x. That's how to define this transformation, okay? Let's try this one, guys. So make sure here is matrix A. That's going to be 3 times 2. Here is 3. Here is 2. That's how to get it, guys. So let's calculate this one. So transformation by using the matrix. Okay, Tx defined A metric times X. So A metric is 1, 4, negative 2 and 3, 0 and 1. X vector gonna be 2 and 1. We already talked about product of metric and vector, right? So this one is 3 times 2. This side is gonna be 2 times 1. So output of this transformation, image of this transformation gonna be what? 3 times 1. Guys, make sure, okay? That's why this one is R3, 3 component. Okay, let's do it. First one is the first row times 2 times 1. So 1 times 2 plus 4 times 1. Second, negative 2 times 2 plus 3 times 1. Third, 0 times 2 plus 1 times 1. That's how to find the image of the x vector under the transformation. Okay, let's simplify. This one is 2 plus 4, 6. Negative 4 plus 3 gonna be negative 1. 0 plus 1 is 1. See that? 3 entries. This one is R3 in the vector in the R3. That's how to define transformation from R to R3 by using the matrix. Let's do one more here, guys, okay? So here is size of A metric is 3 times what? 2, right? 3 row, 2 column. U vector is 2 times 1. That's, of course, this is vector in R2. B is 3 times 1. That's going to be R3. So our transformation is R2 to the R, from R2 to the R3, right? So they define the A times X, right? So we're going to find the image of U first. So TU going to be we defined A, U, right? So A gonna be 1, negative 3, 3, 5, negative 1, and 7. What is U vector? 2 and negative 1. Okay, so you expect the output of this transformation gonna be factor in R3. Let's do this one, guys. This one, 1 times 2, that's the 2, plus negative 3 times negative 1, that's the 3, right? Next one, 3 times 2 is 6 plus negative 5. Third one is negative 2 plus negative 7. Okay, I think everyone already mastered how to do this one, right? So this one gonna be 5, 1, negative 9. That's the, where is it, this vector? R3 vector, right? So that's you find the image of vector of U. Now, this time is a little different. They find X in the R2, in the domain, when you give the image of under the T. So they give the vector. So we have find this one. T, X gonna be U. No, B, guys, right? TX, how can define it? A, X gonna be B. Oh, we're gonna solve system of equation, or you're gonna solve metric equation, right? So A gonna be 1, negative 3, 3 and 5, negative 1 and 7. We don't know the X vector, but R2, guys, make sure X vector is R2. So X1, X2, right? So this one is X1, X2. That's gonna be B vector. B vector gonna be what? 3, 2, negative 5. This is a metric equation, guys. Augmented matrix, guys. Remember, augmented matrix gonna be 1, negative 3, and 3. 3, 5, 2, negative 1, 7, negative 5. Okay? This is coefficient metric. This is constant metric. We're gonna solve augmented metric, guys. All right. So how gonna solve it, guys? You have master all the operation, right? Let's do this one. What do you need here? You need what? So I'm gonna put the negative 3. How can I get the negative 3? Negative 3 times R1, right? Here is what you need, 1. So you have 1 times R1 is right there. So negative 3 R1 plus R2 go to R2. Here is R1 plus R3 gonna be R3. So you're gonna see negative 3, 9, negative 9. This one is negative 3 and 3. Okay, so you have this metric. 1, 0, 0, negative 3 and 3, 14, negative 7. Here is a 4. Here is negative 2. Guys, make sense, this one? Okay, so let's simplify for a second law. So I want to do this one times 1 over 14. Oh no, that's the fraction part. I don't want 1 over 14. So I want to do 1 over 7. 1 over 7, R2 go to R2. So this is going to be 1, negative 3, 3, 0, 2, negative 1, 0, 4, negative 2. Or you're going to do one more time third row. It's fine. You're going to divide by 2. It's okay. So I'm going to do 1 over 2R3. That's going to be R3. You can simplify this one is 2, negative 1, right? 2, negative 1. Okay, so let's do the, here is the pivot is 2, right? Guys, this is a pivot. This should be 0. So what do you have to do? So you need here negative 2. That's going to be R2 negative. Going to be here 0, positive 1. So negative R2 plus R3 go to R3. So you have 1, negative 3, 3, 0, 2, negative 1, 0, 0, 0. Okay, what do you see now, guys? This one. Can you see that? This is what is here. When you see it, guys, here is x1, here is x2, right? So equation is x2 gonna be So row 1, you have x1 minus 3x2 equal x3. Row 2 gonna be 2x2 equal -1, right? So x2 is -1.5. So you find this one. Let's go here. Oh no, this one is just 3, guys. So this one is x1 equals 3 plus 3x2. So you find x2 right there, 3 plus 3, -1.5, right? So this one is 3 over 2. Oh, now you find x vector. X vector gonna be 3 over 2, -1 and 2. That makes sense? So we practice how we gonna find the image, how you gonna find the vector in the domain. Okay, let's do another practice for metric transformation. I give this square. So we have metric transformation, a metric. So how gonna change this square under this transformation T, guys? So let's start with this point 0 and 0. So 0 and 0 change what? Which point under this transformation? So we're gonna have metric 1, 3, 0, 1 and 0 and 0. You're gonna do product of metric and vector. That's gonna be 0 and 0. So this gonna be 0 and 0, right? So second point gonna be, you see this one is 2, 0. So let's do this metric transformation. So 1 times 2 and 2, 3 times 0 and 0. 0 times 2 is 0, 1 times 0 is 0. That's the second law. So this one is going to, this one is gonna be 2, 0. Okay, guys, next one. Next one is we're gonna interest this 2 and 2 point. 2 and 2. So 1, 3, 0 and 1, 2 and 2. So this one, 1 times 2 is 2, 3 times 2 is 6, right? 0 times 2 is 0, 1 times 2 is 2. That's gonna be A2. Does it make sense? One more point. This point is, so this one gonna be A2. The last point is 0 and 2. Last point is 0 and 2. 1, 3, 0, 1, 0, 2. So this one is 1 times 0 plus 3 times 2, that's 6. 0 times 0, 1 times 2 is 2. So this one is 6, 2. Let's just sketch it, guys. What happened this one, right? So let's just sketch it. Zero and 0 is 0 and 0 right there. 2, 0. Right, 2, 0 is right there. 2, 0 doesn't change here. 2. 2, 2, this point gonna be A2. So A2 right there. So that's the A2. This one is 0, 2 gonna be 6, 2. 6, 2 is right there. So that's gonna be this parallelogram. That's changed it. Under this transformation, guys, you say this one is transformation is a T. So each point transform to the different point. That's how to find this transformation under the matrix, guys.